Greetings. I'm very happy to participate in this Congress. My subject participation will be about the effect of bismuth and bore content in glass system inhibitor of the corrosion behavior of mild steel in 1M hydrochloric acid solution. The interest in glasses has led to new studies of their structure. The absence of order in these materials does not allow the application of the usual methods for studying the structures of crystalline solids. However, certain spectroscopic methods can provide important information on the structural units and their arrangement. The use of organic products as steel corrosion inhibitors in acidic environments has a detrimental effect on the environment due to their toxicity and low effectiveness. Characterization technique: infrared and Raman spectroscopy, X-ray diffraction. The various glassy samples were synthesized from ammonium hydrogen phosphate NB2O5, Bi2O3, B2O3, Ti2O5. The reagents are initially crushed in an agate mortar, then introduced into alumina crucibles. A first heat treatment was carried out at 350 Celsius degrees for one night, followed by a grinding. After that, subsequently, the temperature was increased instead of 100 degrees Celsius, and after the molten mixture is then dipped into an alumina mold in the open air. We chose to study the system by X-ray diffraction to verify that is an amorphous phase. The X-ray spectra do not show any Bragg peaks. The absence of diffraction and the presence of bumps correspond to the amorphous state of the glassy system studied. The analysis of the spectra shows that the substitution of bismuth by boron leads to an increase in the intensities of the bands assigned to the metaborate units BOBI and BIOBI. We also observed the disappearance of the BO inversion in BO3. We also noticed the disappearance of the BO3 orthoborate groups. This can be explained by the conversion of orthoborate units into metaborate units. Measurement techniques: electrochemical measurements, polarization curve, and spectroscopy, electrochemical impedance. Compositions of the samples prepared within the system. Electrochemical impedance measurements. Note for this figure that at all concentration ranges of S1 do not perfect semicircles due to frequency dispersion. The loop diameter increased with increase in inhibitor concentration. The larger loop size is due to the adsorption of the inhibitor molecule. It is observed that the addition of inhibitor increases the RCT values and reduces the CDL values. The decrease in CDL is due to the increase of the thickness and the electronic double layer. These observations suggest that S1 works by adsorption on the metal surface and thus causes the CDL values to decrease and the RCT values to increase. To increase the charge, the transfer resistance RCT values best efficiency is at 150 ppm in the order of 79% for S1. Polarization curves. There is a shift in the corrosion potential towards the more anidic values. Conclusion: the substitution of bismuth by boron leads to an increase in the intensities of the band assigned to the metaborate units BOBI and BIOBI. We also observed the disappearance of the BO inversion in BO3. We also noticed the disappearance of the BO3 orthoborate groups. This can be explained by the conversion of orthoborate units into metaborate units. The inhibition efficiency of 51 is temperature dependent, and the inhibition efficiency decreases slightly with increase in temperature. The addition of 51 leads to an increase in the corrosion activation energy.